Welcome back to the School Science Shed, and this is episode 3A in a series of videos which are designed to help you revise for your GCSE Physics exam if you are studying in England. If you're not studying in England, I think the content will still be helpful to you because physics is the same everywhere, but you do need to be careful that the content matches your curriculum. So check what you're supposed to be learning and make sure the stuff we're covering is actually relevant to you. And the same really goes if you are studying in England too. Do not use this video as your only revision source. Make sure that all of your syllabus is covered by reading it carefully, please. So it's episode 3A. What do I mean by that? Well, originally I intended to do episode 3 where I looked at energy calculations, but on reflection I think that video will be too long. And energy calculations take quite a bit of concentration on your part. So what I've done is I've split it into two, 3A and then obviously 3B. And in 3A, I'm going to look at calculations involving kinetic energy and potential energy. So let's make a start. Now, if you watched the last video about energy stores and energy forms, you will have learned that kinetic energy is the energy that objects have because they are moving. And because you're smart people, you will have worked out that it's pretty obvious that the amount of energy that an object has if it's moving will depend on two things. One is it's how much of it there is to move, so that's its mass in kilograms. And the other factor, which is obviously going to affect the kinetic energy, is how fast the object's moving. And that will be the speed in meters per second. But it isn't quite as simple as it might be, so you don't just multiply the two together. There is quite a complicated formula. So if you want to find out the kinetic energy of a moving object, you have a half multiplied by the mass of the object multiplied by the speed of the object squared. And I want to make it really clear, you only square the speed. Don't square the mass. Don't square a half. Only square the speed. And if you were writing it in letters, which can be certainly easier to write down in an exam and probably easier to learn as well, you would write E for kinetic energy, a half mv squared. We use V to represent the speed. So kinetic energy is a half mv squared. Let's have a look at how you might apply that to a question. So this question says a small car of mass 500 kilograms is moving at 20 meters per second. How much energy is in the kinetic energy store? And before we answer that question, because this is the first time I've spoken to you about how to do calculations, let me give you a recipe to follow which will work for most calculations that you do. So if you've got a calculation, this is what I recommend you do. First of all, I recommend to take the numbers out of all the words that are in the question, that you do a summary of the information that you have in the question. And that will actually help you to pick the right formula. Now, I'll show you how that works in a minute. The other thing it will do is it will help you to get the units right. Because if we go back to our formula, this formula only works if you have energy in joules, mass in kilograms and speed in meters per second. So you've got to make sure you're using the right units. And when you do the summary, that's a good time to think about units. In terms of the mark scheme, there's very often, I mean not absolutely always, but very often a mark simply for using the right formula. So it's a good idea to write the formula down. Don't make the examiner guess which formula you're using. Tell the examiner, here is the formula that I'm using, and then you're going to get a mark. Even if you make a mess of the rest of it, if you've written the right formula down, you are going to get the mark. Now, once you've written the formula down, you need to make sure that the formula is giving you the quantity that you're trying to calculate. So you're going to need to rearrange the formula. And it's best practice to rearrange the formula before you substitute the numbers in. But actually at GCSE, it doesn't matter which way round you do it. They both give you the same answer, and nobody's going to worry too much about you doing things technically the wrong way around if you put the numbers in first. So those two steps you could do in either order. What I would say is, if you're confident in your mathematical ability, rearrange the formula first. And if you're not confident in your mathematical ability and you don't like changing the subjective equations, put the numbers in and then do the rearranging afterwards, because it's easier to do it that way. And then finally, when you've got the answer, write it down with the unit and underline it. And the underlining is a good idea because it really helps the examiner with the marking, because in most mark schemes it will say if the candidate has written the right answer down, they should get full marks and the examiner doesn't need to look at your working. So if you clearly flag to the examiner where the answer is, it just makes it really easy for them to find it and mark it. And don't forget the unit, because if you do forget the unit, you will automatically lose 1 mark. So here's the question again. So the first thing to do is to write a summary of everything that's in the question. And that's what a summary looks like. So I've read the question and it tells me that the mass is 500 kilograms. So I've written M is 500 kilograms. It says the object is moving at 20 meters per second, because I know about units. I know 20 meters per second is a speed. So the speed is 20 meters per second. And then it's got this slightly strange wording here where it says how much energy is the kinetic energy store. But if you watch the last lesson, you'll know that that is just basically asking you how much kinetic energy does the car have. So that is our summary. Now what I would do now is I would ask myself, do I know a formula that has got those 3 things in? Do I know a formula that's got M, V and E? And the answer is yes. It's that one. E equals a half mv squared. So I simply write that down. And then what I need to do, well, I don't need to rearrange this equation because it's asking me to find E. If it was asking me to find M or V, I would have to change the subject to the equation. But I don't need to do that because the subject to the equation is already E, which is what we want. So all I need to do is to put the numbers in. And when I'm putting the numbers in, I'm not going to go back and read the question. I'm just going to go straight back to my summary. So I've written 0.5 because that's what you type into the calculator if you are having a half. So it's 0.5 times mass, which is 500, look, times the speed squared, which is 20, and it's only the 20 that's squared. So I just put that in my calculator, and when I do that, it comes out with the answer 100,000 joules. So I underline that, I make sure the units are there, I have finished, I have answered that question. So let's have a look at a more challenging question. So this is more challenging for a couple of reasons. We'll see why in a minute. So we've got a tennis ball. It gives us the mass of the tennis ball. It tells us the energy, but it asks us the speed. How fast is asking us the speed. So let's do a summary. Now, this is what I mean about getting the units right. It's given us the mass in grams. But for the formula to work, we need the mass in kilograms. So when I'm doing the summary, I write down mass is 60 grams. And straight away I think, wait a minute, that unit is not the right unit for me to use in the formula. So I need to get it into kilograms. And you get kilograms from grams by dividing by 1,000. 60 divided by 1,000 is 0.06. So I write that down straight away. And then the next thing I need to do is I need to have a look at what formula I'm going to use. Now, I know what formula I'm going to use because I know it's about using this formula. But we've got a bit of a problem here. This formula is not giving us velocity. It's not giving us speed, sorry. It's not giving us the speed. It's set up to calculate the energy. So we need to rearrange it. And the way I've rearranged it is I've said, first of all, I need to get V on its own. So I need to get rid of the half. So I multiply both sides by 2. That gets rid of the half. And I divide both sides by M. That gets rid of the mass. And you could, at this point, put a square root in to find v rather than v squared. But I just decided not to do it that way. I decided to put the numbers in first. So 2, because that's in the formula, 75, E is 75. 75 there, divide by the mass, which is 0.06, and that gives us 2,500, sorry. But that is v squared, so we want the square root of that, square root of 25,000, and that's 50 meters per second. So that's an example of how you might calculate the speed if you knew the mass and the amount of energy. I think that's quite complicated. We've got to take a square root. We've got to change some units. If you're not very confident, what I would do if I were you is pause the video, go back and look through it again. If you are confident, let's go on and have a look at another calculation. So let's take a look at gravitational potential energy now. We've done a couple of calculations with kinetic energy. If you watched the video last time, you will remember that gravitational potential energy is energy that things have because they are high up. And again, if you thought about it, pretty obviously, how much energy something has because it's high up is going to depend on how much of it there is, its mass in kilograms, and it's also going to depend on how high you've got it. But there's a third factor which is much less obvious, and that is the strength of gravity. So if we compare these two hammers, one is on the Earth and the other one is the same distance above the moon, they've got different amounts of gravitational potential energy because gravity on the moon is a lot weaker. Every kilogram on Earth is pulled down by a force of 10 newtons. But on the moon, every kilogram is only pulled down by a force of 1.6 newtons. So that means the potential energy of the hammer on the moon is a lot less than the potential energy of the same hammer, the same height above the surface of the Earth. So this is the extra factor. It's the strength of gravity in newtons per kilogram. That can also be called gravitational field strength. But if you think about it, it's a gravitational field that's causing the strength of gravity. So strength of gravity and gravitational field strength, they are just the same thing. So that's the formula. If I was writing that in letters, I would write it E equals mgh. So let's have a look at using that. Here we go. Here's a calculation. It's telling us about a glider, which is above an airfield, tells us the mass of the glider, and they've included the pilot, because if you think about it, gliders have got very low mass, and an important element of the mass of a pilot and a glider is the mass of the pilot themselves. And it's also told us the strength of gravity on Earth is 10 newtons per kilogram. So let's see how we answer it. First thing we do is a summary. So we've got a height. It doesn't say height, but look, it does say 1,500 meters above. So that's what tells us it's the height. It tells us the mass. It asks us the gravitational potential energy. And so there we go. GPE is question mark. And it tells us the gravitational field strength is 10 newtons per kilogram. So we're asking ourselves, do we know an equation with height, mass, gravitational potential energy and gravitational field strength? And naturally we do, because it was on the last slide. So we write that formula down. And it is asking us for the gravitational potential energy. So we don't need to do any rearranging. We can just put the numbers in. So the mass is 320. Gravitational field strength is 10. The height above the ground is 1,500 meters. Put those all in. Do the calculation. We have 4,800,000 joules as the answer. So what we've seen in this video is we've seen how to do calculations involving kinetic and potential energy. There is some more to do, which I will do in the next video, which will be episode 3B. I hope this has been useful for your revision. If it has been useful, give it a thumbs up. And if you've got any questions, put those in comments and I'll answer them either in a video or in the comments section by responding to you. I've really enjoyed explaining this to you. I'm very much looking forward to the next episode. And until then, good luck with your revision.